Hello, everyone, and welcome to today's Tech Talk on testing HVAC safeties. My name is Sherry Adams, and I'll be your moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted, and this will minimize any background noise or feedback that could distract from the presentation. Using the Q&A function as well as the raise your hand function. So if you do have a question, please put those in the Q&A or raise your hand. We will also be recording this Tech Talk, and it will be available on our website under the resource section. Today's presentation is brought to you by the Central Chapter Board. So I will turn this over now to Rachel, the Central Chapter President. Welcome, Rachel.
Thank you, Sherry. Like Sherry said, welcome everyone. Thanks for joining us today for the September Tech Talk. It's a good thing we're ahead of the game, as our entire board was planning on the October Tech Talk. So, and I'm sure that's completely my fault. I somehow messed that up and got us all rolling for October, but thankfully it worked out in the end, and it's great to see everybody here, so thank you. So today's Tech Talk is a 21-minute safeties webinar, mainly focused on air handler safeties. You'll see that members of our Central Chapter Board participated in creating a whole number of individual videos of ourselves actually testing a variety of safeties. As you're likely aware, there's many ways to test a safety, just like there's many different ways to eat an Oreo or a peanut butter cup, or I won't use Dave's example. But these videos are samples of many different ways that you can test a safety. We're offering this as a way that you can choose to do it. You'll notice that also that each video was done a little differently. Some were selfie videos, some had people holding the camera, and you might want to brace yourself a little bit. We might have a little bit of the Blair Witch Project video motion for some, and you'll note that we are not professional videographers, but I think all in all it went reasonably well. So we are going to be pausing throughout the video at various intervals, essentially after each safety, just to have a moment to see if anyone has a specific question regarding that safety or anything in general. So please hit your raise the hand button, or feel free to write the questions in the chat window. So let's get into this. All right, so like I mentioned, Central Chapter Board and Friends, testing safeties. Let's hit the next slide.
Oh, I'm sorry.
The disclaimer will come to the video. So while it's highly likely that we test safeties on all types of equipment, and we all have our own means and methods, it never hurts for that brief refresher opportunity. So we could have focused this entire presentation on one safety. We could have said, hey, let's just focus on freestats, but we didn't. We thought that it would be good to focus on pretty much quick snips of various safeties. Creates a great learning opportunity or just a refresher opportunity. So what does this mean? This means that we're not addressing every single topic. I mean, we only have 20 to 30 minutes, so we're not hitting all the whys, whats, wheres, and whens. So let's get into the video. So just give us one brief moment while we unshare this and share the video. Can we get a confirmation that you guys see the video screen?
Yes.
Thank you. So not to pause it on the disclaimer, but just wanted to put that extra emphasis out here that these videos are samples. So when we're out there on site, we obviously we're out there with contractors, the controls contractor, the mechanical contractor. These are systems that have been pre-tested. Each company has different thoughts and processes regarding who's allowed to push buttons or not push buttons. So just want to make sure everybody is aware that this isn't just saying, hey, the BCA says go and push buttons, because that's not what we're saying. We're just giving kind of a brief overview of how safeties can be tested, but you have to be in the right circumstances to make that happen.
So here we go.
On the Magna Helix. We're going to remove the tube from the low. We're going to still put the Magna Helix connection on the high. This one should trip around 3 inches. It's really starts with -3. You can release the air. Remove the hose and be sure to reconnect the tube on the low when you're doing a suction. So this was a suction safety, and obviously there's multiple ways that you can do that, but we wanted to just pause and see if there were any questions regarding this so far.
Rachel, no questions have come in.
Okay,
Questions move forward.
no questions, move forward.
So as you watch that video of Rachel's for static pressure safeties, is there anything different do you have to do if the static pressure safety are actually in the temperature control panel? And I would say you absolutely do. You still need to test it, not at the physical device as what she was showing, but you have to test it for the location that the sensing tube is at, so that you can then test or verify the integrity of the sensing location. So that's what we're going to do. All sorts of excitement on the job site. Not that it's overly important, but we worked to disconnect that key from there, then connected our poly tubing to our little test assembly with the test bulb and the Magna Helix. And no one's really mentioned that we're giant advocates of just using a Magna Helix versus a digital gauge. Digital gauges oftentimes maybe have a little buffer in them that they're not completely instantaneous, and what's 0.05 inches amongst friends. Just a little test bulb or whatever, have to make sure it's in the right direction, and we're going to go and a gentle hand.
Five inches.
5 inches. You audibly heard the unit turn off. So we're going to hit the reset panel, but one thing before I do that, and I have that photograph earlier, we are not big advocates of only labeling the covers, because if anybody ever takes the covers off, how do you know that someone won't put PS1 over here and PS2 over there? And there was no labels on the back. So hitting the reset panel here. and nothing really loud is going to happen here. Oh, there goes a couple relays. And we're off to the races of starting up the unit again. So I'm back. I made a mistake. As you see here, there are multiple safety resets. There's this master reset, but then there's also the resets on the static pressure safeties themselves. Sorry, I'm doing the camera backwards. I'm not an expert at this. So the resets have now subsequently both been pushed. The high safety, which was this guy, and that guy, which then made the unit start. So, as my wife says, I'm certainly not perfect.
John Bellani.
So that was sort of an example of it was an example of a remote switch. And obviously there's the pros and cons between why you choose to put it in the panel versus out on site, or running a wire throughout the space versus running a poly tube throughout the space. But are there any questions in regards to that part of the video?
I mean, Rachel, we did receive a comment after the first one that said, is the testing this, or comment is the testing that way doesn't confirm the plumbed correctly. So I think the second video just answered the question of the different methods to see the plumbing.
Okay.
We did have a question just come in. How do you test remote negative pressure switches?
Right, the suction, remote suction.
If we're going to say, well,
Yeah.
I think that is still, negative testing for negative, right? You still, since you're using a pump on a main, well, the hand little pump or whatever, that's why we're flipping the tubes around. And as Rachel indicated, right, the tube was measuring on the low, but we took the low tube off and tested on the high because differential is differential. There is a tool out there now that does actually have a vacuum in it that you could actually test from a vacuum perspective or whatever, but that right now is not in our arsenal of tools.
Right. If you look at the first video, like Dave said, that actually was a negative. And whether that device is in the panel or out on site, you can hook it up that same way.
So we're going to hit the next video, and if there are additional questions coming on, we can add them up. All of us to answer those.
And I wanted to add my 2 cents in, which I've been known to do, and talk about a bad install situation. And I know we've been talking about static pressure safeties, and I want to give an example of that. Although this was from building pressure, it could have very well also been a static safety as well. And this is from a BCA TechkTalk back in 2018. On the left, there's a picture of a pneumatic fitting, and that was on a building pressure sensor, but very similarly could have been on a static safety. Through my almost 30 years of working, I've either installed, tested, seen, touched, probably thousands of a standard barbed pneumatic fitting like this. And if you look in the middle picture, you see the 2 poly tubes. And this fitting on the left, the most interesting thing is it wasn't hollow. There was no way for air to pass through that pneumatic fitting. It was actually not hollowed out. So this is a, manufacturing defect. So my whole point is just to say it is essential, it's critical when you're testing safeties to make sure that you're testing from the sensing element and not just jumping out the electronics. Because in that case, it's very likely the sensor would have worked and it would have tripped safety. But the sensing element going through this fitting would have never worked. And as the case I had, never worked for the building pressure control. So, and then last point I want to make is it's essential in our attributes number 10 that we provide that constructive input and specifically the resolution of system deficiencies. I really believe what differentiates the BCA and the providers and the members are people, we are passionate about getting to the root cause. I will say this took quite a while to troubleshoot. We had to take about every piece of poly tubing apart to finally find this. It did not happen in one day, but I really believe that's what differentiates us. So make sure you're testing from the sensing elements of whatever device it is, and thanks.
Hey, it's Scott Weaver. I'm going to demonstrate two devices common to humidifiers. Make sure you're wearing proper PPE. A high-limit humidistat and an airflow switch are two devices commonly installed downstream of the humidifier, with a high-limit humidistat installed sufficiently downstream of the plume. The high-limit humidistat functions to close the steam valve if the sensed humidity exceeds the set point, typically 85 or 90% RH. This device is best tested seasonally when the outdoor air dew point is less than the zone dew point. To test this device, increase the zone or return relative humidity set point and observe the humidifier valve open and discharge humidity rise. Once it rises to 65 to 75% RH, adjust the set point dial on the humidistat to be below this value. You should hear the humidifier valve closing, then visually verify it has shut. If there's a binary input to the control system, you can also verify the action is reflected at the front end display. After testing, set the set point dialer and return the zone or relative humidity set point back to their respective specified set points. To test the airflow switch, disconnect the high side from the device. This will equalize pressure to both ports, and the device will no longer be made. Again, you should hear the humidifier valve shut and visually verify it closes. To set this device to an appropriate pressure, use a squeeze bulb and magnehelic pressure gauge, like Rachel used in demonstrating the low suction safety. Remove the cover and adjust the set screw as needed. When complete, return the cover and reconnect the tubing to the high side of the device.
Any questions on what you just saw? And while we're waiting for a question to crop up, we had also talked that in addition to that testing strategy, that letting the humidifier actually ramp up and see to the actual set point for the high limit to see it kind of pushing it back down, pushing the valve closed, because oftentimes you want to verify that the high limit kicks in before the fire alarm device kicks in. So it's nice to verify that you actually have entrainment in the air sufficiently before that smoke detector, duct detector, really. Any questions? Everyone?
So we're going to go and test a vertical steam facing bypass coil today. That looks something like so. Vertical steam facing bypass coils are always a challenge in Wisconsin. We certainly have ways of wanting to install them. Getting involved in projects late or whatever and seeing the install sometimes also begs questions. Coming to site the first time after installation's already taken place always allows you to see different things. Vertical steam facing bypass coils. Freestats are mounted on the top, but a couple issues that we're seeing right away. Number one, the element is actually in the bypass stream, which is going to bound a trip, and installation manuals indicate that the freestats are supposed to be mounted vertically, where the bellows and the tube coming out is vertical. So this seems to be a problematic installation. You might recall an earlier installation where the freestats were rotated 90 degrees and all sorts of other chaos. But now this is a textbook installation with the freestat up on top, line running vertically down the element of the coil, and the contractors have already covered up the remaining freestat element at the bottom. What's behind me is the master freestat panel. Little interesting, and we spare no expense at the state of Wisconsin, is that each freestat is independently wired back to a relay so that if a freestat trips, we'll know exactly which freestat it is that physically tripped. The red light is the safety light, so when we do our little experiment here, we'll see the red safety light go off, and then we'll see one of the other red lights going on for the freestat element that tripped. And we have gone through the energy management system so that we'll know that position, relay number X or whatever is associated with freestat element number coil A-2, for example. So we're in the unit now with our assistant, and we're going to go and use just simple carbon dioxide or whatever cleaner to try to trip the freestat element. So we should know when the unit turns off. Ready to go, Jeff. And pop goes the air handling unit. Now the steam coil we're both freezing our katukas off, but the steam coil is going to go hot now, so we're going to get warm quickly. So as indicated before, we're now at the same relay panel, and that safety relay that was over there is now non-illuminated, which hardwired safety shut down the air handling unit, and now the freestat element that tripped is that relay over there. I'm not going to bore you to show you on the energy management system, but I will let you know that that does work also. So in a moment here, we're going to hit the reset, but we don't let any testing go without saying, hey, what else can we look at? So we're going to go and revalidate that one of these 4 air handling units, when it goes off, that the other 3 kind of ramp up. So, but we'll show you the reset in a moment. So another important thing to note and to see, it's just that the frequency drive is showing a hardwired shutdown, off and off on freeze. And if we go down here, though they're not quite labeled yet, one of those relays is the start stop, and the other one is the safety relay, so that's shut down. So as you can see here by the other fan, it's still running, that those 2 relays are up. And this fan now is slowly speeding up along with its 2 cousins on the other end to make up the difference of the other one. Now, I would say that the units are running a little slower than I would want them to, but this should be a rare instance of this occurring. So, because I like pushing buttons, even though we're probably not supposed to push buttons, I am now going to reset the freestat. So, again, we're showing the panels currently like that. I'm going to hit the reset here. And now the freestat element that was tripped over here is now off. The good safety light saying that I'm good is there. And if I stop talking, you can hear actuators starting to move and everything's ready to roll. So that's a way of testing our vertical steam face and bypass coils. Roger that.
Any questions? So that was a vertical steam face and bypass damper, or coil face and bypass damper. And Dave was able to show some installation issues in addition to the functional aspect. Any questions on that?
We have one question that came in. Can you damage the coil by spraying the compressed air onto it in an attempt to trip the freestat?
Okay, I am not aware of any damage ever occurring to a coil. Now, keep in mind that we're just spraying it for a couple of seconds. So it dissipates in pretty darn quickly to reheat back up and be able to start and enable the unit again. Additionally, the valves typically open on a freestat trip, so you're heating the coils immediately.
But that is a worthy question, because I think we've all kind of just for grins sprayed the CO2, the propellant in our hand and saying, "Ow, is that really cold?" So I mean, if you're cold, if you had a small coil and it was dry and you sprayed it extensively or whatever, maybe. But I have actually never heard of that circumstance. But as we'll see in a video in a moment, there are other methods, and CO2 is certainly a way, but it's a little crazy because you're spraying something that's literally below zero at it, so it's necessarily isn't that hard. So
right.
We'll continue, and we'll we'll see something additional to that momentarily. Hey there, me again. We're going to test now, along with the aid of the fire alarm contractor, one of many means of shutting down the air handling unit with the duct detector, which is located over there. But the test switch is located over here. So we're going to utilize the test switch to turn off our air handling unit. So Ryan, can you let her rip here? That was at the bottom. So hopefully that's coming over here. The control module went to solid green, indicating a fire alarm. Our duct detector went into duct detection mode based on the test switch. And we heard the actuator turn off, so our air handling unit turned off. And if we go to our drive,
Are you ready to reset?
it is showing it off on safety. So that's it. Yeah, why don't we can put it back.
Okay.
So now we're just gonna hit the reset. Yeah, if you haven't done it already.
He said you can reset.
So we took the test switch out of here at the fire alarm, but now it actually has to get reset at the fire alarm panel because it was actually a trouble. So our lights should come back here. Our duct detector is blinking safety green. Our safety module hasn't released quite yet. And there it goes.
Come back up.
We're good to go. So fire alarm is certainly needs assistance or whatever, because there is another trade involved, not just Division 23. Signing off.
So, fire alarm, the key switches, they're a nice convenience item. They're not required for code. Those are more like a convenience item for facilities, for access, especially if there's access issues, or if they're ever doing any programming or changes, they can more easily test versus getting access to the duct detector itself. The LED also, it's nice to have for, you know, when they're farther out of reach. So, you know, really for annual or semi-annual testing, smoke is typically required. So smoke is another way to test fire alarm, and we like to use both options oftentimes because we've had many experiences where smoke might cause the fire alarm to initiate, but the key switch doesn't, or vice versa. Maybe the key switch worked, but the smoke didn't. So it's always nice to test the sensing tubes as well. Any questions?
Well, I think you partially answered the question. Are there any
Okay.
practical ways you know of to trip the duct detector at the device rather than with the test switch?
Yeah.
Well, there's also a magnet,
Mm-hmm.
typically also.
Yeah, and a magnet kind of does the same thing as the key switch. So, you know, and I guess there's also pulling the relay, which.
Well, that would demonstrate the wiring part of it,
Right.
on the controls.
Yeah.
Today we're testing a CO2 sensor. Current CO2 is at 270 parts per million. Our limit is 700 parts per million. One way to test the CO2 sensor is to either use the CO2 test gas, or if you don't have the test gas, the easiest way is just to blow into the sensor. As you can see, sensors are going up, maybe not enough hot air, or maybe too much hot air.
This is the remnants of the 1900 ppm. CO2 is coming down, dropping back down to the 200. Our damper actuator went up to the max CFM and is now dropping back down.
So that was a great demonstration, and Dave is just kind of clicking us back to, so you can see the before screen and the after screen of the controls.
So this one here is the before, when it was just in control, operating at minimum CFM. And then here we're the maximum cooling set point. And got very good on the pointer here. Here we go. And as they mentioned, this is the residual effects. You know, we didn't have all the production capability of filming this at the same time as they were breathing on the sensor. But this is it actually coming back off of maximum. The CO2, I think, is also coming back lower. So the software sequence was performing as directed. So we'll watch one more video here and then we'll go back to questions. I think there might be
200 ppm. CO2 is coming down, dropping back down to the 200. Our damper actuator went up to the max CFM and is now dropping back down.
Okay, so one way we can test the safety if you don't have canned air on you, or for some reason you can't get that to work, whatever your dilemma is, you can do the hold the button test. So I'm gonna just do that here. We just hold the button in at the FreeStat panel here, and we just hold this in for a few seconds, and we should be able to hear the unit shut down. You got to hold it in, but you should be able to hear valves close. And if you have a helpful hand, you can also check the dampers are shutting. Outdoor damper shut, return our dampers open, whatever your sequence of operations calls for. And then when you're done, you've heard everything you need, seen what you need, just release it, and the unit goes back into auto, just as we expected.
So any questions on either the CO2 or on the FreeStat test? Once again, means and methods, there's many different ways. So these are a couple of demonstrations of options that are out there for you. Okay.
We have a comment in the questions.
All right. So another way we can test our high static safety without doing the squeeze bulb, if you left that at home, or if you already knew what the setting was at, you just wanted to test the safety in hand or do a repeat test for one reason or another, we can blow into the tube. So got it tied into my high side on the switch here on the transducer, and I'm just gonna blow into this just enough to hear it pop. So give it a second, we'll hear it click, and it should shut down. A little blow there, shut it down, and that's all we got to do.
All right. So Mike, you said we had a comment?
In the question and answers, there was just a comment to verify the CO2 sensor base is sealed from the wall cavity. I find negatively pressured rooms. Positively pressured wall cavities will provide reversed flow into the sensor from the wall, reducing sensitivity.
So I can speak to that because I did the testing on this. This was in a conference room, open to adjacent spaces. The CO2 sensors that we've been using do have a foam seal to go onto the back of them. Most of the time you do not see a installing contractor sealing conduit or sealing that wall cavity, but they will put that foam backing seal between the actual device and the wall. There was another comment that was in here about ambient and set point to activate. I believe ASHRAE has your typical outdoor air conditions are really based on where your location is. Outdoor air is somewhere in the 300 to 450, 350 to 450 ppm. They want the activation to be 400 to 500 ppm above ambient. So that's where our activation set point. That's why you need to bring your local setting above that activation set point. Going up to the max of the device, which is 2000 ppm, will definitely set it off. And that's why you've seen the 1999 in that screenshot. What you didn't, like I think Dave said earlier, what we couldn't do at the same time was to video in one room and in the other room at the same time to be able to see as the device actually dropped back out of that 1999 and was dropping down and then going back up and settling out.
Thanks, Rick. Were there any other questions or comments?
I don't see any coming in at the moment.
Okay, so on the screen, you'll see that we have additional means and methods, once again, samples for testing air handler safety. So you can see like freeze, stat, or low limits, how we listed a handful of options out there, as simple as like an ice bath, or maybe sometimes they use software protection. But this is not an all-inclusive list. This is simply, these are simply samples of means and methods that you could utilize. High and low static, we had, you know, magnehelic with hand pump, battery operated pump with set point, blower sucking on the tube, which you saw Kenny demonstrate. Thank you, Kenny. And or pulling relays out. So, but as I think John maybe mentioned in his part, it's very nice to be able to incorporate the sensor aspect of the testing. When I know when we've used compressed air and freeze stats in the past, there might be like 10 or 15 stats. And while you don't have to technically have the unit come on and off for all 10 or 15 of them, we like to make sure they all click because we encounter often some of those sensors themselves that don't function. So it's nice to run through them all. Water detection, there's test methods there. We did not show an example in this particular presentation. Fire alarm, other software safeties. So there's many safeties out there. This was just a sampling of safeties. Any other questions that you didn't ask along the way? For ourselves, you know, we hope you enjoyed this webinar. I know we like to have the webinars that we can like take some information and go straight out to the field and use it. And hopefully, you know, now that you've seen some of these, maybe it'll give you the drive to make.
Rachel, we have one more question that came in.
Sure.
We had one more question that came in, Rachel.
Okay.
What methods have you used to test fan failure sequences?
Fan failure sequences, multiple, you know, with fan failures, there's fan arrays, which are very common now, which bring in a whole different set of things to think about. For example, you know, are you controlling your supply and return on static pressure? If you are, that simplifies things, but often we find that people are controlling supply on static pressure and then return is ducted return. And so then you have to start thinking about things like if you're controlling them based on a offset, you know, like a frequency offset or something like that, then you could maybe say, hey, if one supply fan fails, my new offset is A. If two supply fans fail, my new offset is B. Otherwise, your returns are just going to continue to follow that offset and you'll be returning too much when you're failing supply. So on an array, we'll fail one and we'll watch what happens to the drives. They should ramp up to maintain their static pressure set point. The return should follow accordingly with those little nuances we talked about. We'll fail two. We'll fail as far as we can see until the supply fan array can't maintain the static pressure set point in that given condition. And then I know I like to, not everybody, but I like to do a full fan failure also. So I can see like if you lose the supply side that the return shuts down. Or vice versa, if you lose all the return fans, is the intent of the project to shut the whole unit down, or are they still going to control the supply? So every place has a different process or intent.
I guess one thing that I would like to just chime in a little bit also, especially more on fan walls and, you know, and everything is almost like being wired in like extension cords. You know, there really is arc flash concerns. So you really have to really incorporate Sparky, you know, when you are, you know, when you're working with 3-phase and stuff like that, then, you know, that isn't something that I would recommend a commissioning aid provider, almost said agent, and I never say that, and to actually help facilitate that, just for the safety concerns and arc flash, because that really is an important aspect. And it's, you know, as things get more sophisticated, you have to keep on thinking of safe, sophisticated ways to test.
It is true. Historically, a lot of the work we've done has been drives outside of the unit, but it seems a lot of times with these fan arrays now, they're coming with those ECMs that are all together inside the units that are a bit more sensitive.
I don't know if any of our other central chapter folks have any other insights that they'd like to provide, or do we?
We did. I mean, there was some more. He had some more feedback. I mean, he said specifically on how to simulate a fan failure using a VFD disconnect, HOA, etc. And additionally, big difference between getting a VFD communication failure with the drive turned off versus the drive sensing an abnormal current.
I guess maybe the other little inside baseball stuff right on drives, right, is that a lot of drives out of the box, you know, that status contact that the controls all want to use is oftentimes just a true, my VFD is running through the starter or the magnetic contactor in their starter, if you will, that is allowing current to flow through it, but you really don't know if current is actually flowing through it. So that status has to get programmed based on torque or amperage, and that's oftentimes another set of parameters that has to get instituted on those drives.
There's also a software through your BAS. If you do a comparative between your output and your feedback, if your output your feedback deviates from your output by so much for X amount of time, that can be your fan failure. So it can be a software-driven failure also. Which I think to John's question about the big difference between getting the VFD communication failure with the drive turned off versus the drive sensing, you can do that through software in the BAS.
Great.
Some other people also use, I've seen it before also, where you can use the relays on specific VFDs. It's not as common, but you can use that as a failure point, as when the relay opens, you lose the circuit for the VFD versus using a current switch.
Well, great. I think that is all the questions I am seeing. Rachel, thank you and the whole Central Chapter Board for your time and expertise today. And just as a reminder to everyone out there that the annual conference is coming up on October 7th and 8th in Toronto. It is a hybrid event, so we hope that you will register either in person or virtually, and all the details are on our website. And in addition, if there's any questions that are just popping up that we don't get covered, Rachel, if your group is open to answering anything offline, I'll make sure anything gets over to you. So on behalf of BCA, I'd like to thank everyone for attending today's Tech Talk and hope you all have a great day.
Thank you.
Thank you, everyone.
Thank you.